Hello, so welcome in this devlog number 5. So today we will continue, we'll continue, not quite. So yeah, last time I was trying to remove this getContextCursor thing, and what I eventually realized is that this was in fact related to the template context mechanism that I have in place. So it's we have this clangParser, and if you were already there in the last session, the issue was somewhere here. So we were reaching this point and we really needed the context cursor to get access to the argument cursor instead of the current cursor, because when we were trying to resolve this type, at some point the type that we were resolving was a const reference. So we would in fact reach which location is it? Yeah, this one, for instance, that's where you check for the const part of the type, and when you find that, you try to first resolve the base type itself using the base type declaration cursor, and that's where the problem comes from. When you get to this declaration cursor, there's no type ref related to the current argument that you're parsing in this declaration. So that's where you lose track of this argument, and it was the same in fact just before, because we would also need to resolve the reference part. So we would remove the reference and resolve the actual base type here using the type declaration cursor. So this is the reason why we were using track of the argument cursor. But then what I eventually realized is that all this mess in fact is just to lead us to a proper resolution in case you have a template class. So when you're resolving a template class, you need to go this way. And in fact, there is a much simpler option, since anyway, every time we enter a template class, we push that class as a template context on a stack also in the type manager. So here all we really need to do is check if we have such a context, and if the type, the base type, at this point there shouldn't be no more const or reference or anything, just a very basic type. So we check if this basic type is ending with a angular bracket. That's angular bracket. Yeah, say so. And in this case, we can use this parseTemplatedType. In fact, this function will rely on the fact that there is actually a context, and it would produce an error otherwise. Okay. So this was for the part where I was trying to fight to remove the context cursor thing, and eventually it was working fine this way. That's why, I'm now handling this template context properly with this type resolution section. Then I remove the context cursor functions completely. Oops. So in there we don't have those context, not searching here, context cursor thing. And now that we are at it, actually I could also, I've been doing a few experiments here to try to understand what's happening, and all this is not relevant anymore, so this can be removed. And then also this one. and that. So a bit of cleaning. Okay. Next thing was this. Yes. I thought, okay, the binding generation part is taking a bit of time now, so it would be good if I could at least start profiling a little bit. And I've been investigating what kind of profiler we can use, and eventually I found this GIT profiler thing. Yeah, wait, oh, I mean, it's supposed to be right in the base. Is that it? Oh yeah, I mean, I didn't expect this to be the namespace. Anyway, so relying on that, in fact, I figured out that we can use the high-level profiler here in the code, and we can get some profiling information from that. In fact, I tried another profiler before that. Don't even remember the name, and I found that on GitHub, and it was pure Lua, of course, but not really optimized as this one. And in fact, when I was trying that one, it was taking ages to generate the bindings, and I didn't even complete a single run. I had to kill the process. It was way too slow. Whereas here, it's working fine. I mean, I can generate some output like that, and it's telling me already that asName is a function that's taking most of the time, apparently, asName row also, and so on. But, okay, so where do we use that? We use that right at the root of the NervBin application, and if we provide this profile argument, then we require this module, and we start profiling. F is for displaying the function name, L is for displaying the line number in the module, and I5 is sampling resolution. So those arguments are described here. So I, L, and F. But the issue that I have now is when I specify the L argument, I get normally the module name and the line where those functions are called, except that for me, all the modules are really just string. I mean, they're called just string, which is bad, because yeah, you can't really tell from which file this is. So that's where I am right now. That's this here. So trying to add the support for that, I eventually realized that I need to modify a bit the way I load a module. And in fact, that's done in the setup function here, where I have this load module function. I get the content of the file, in fact, and the name of that module. And then I'm going to do load string with that content and the module name. I was expecting this load string to give this Lua chunk this module name, but it seems it's not the case. Not quite sure why, but I think there's another way, and I can use the Lua function, the C++ Lua function, Lua manual 5.1. My, that's so slow. Okay. The function I'm thinking about is Lua L load buffer. Okay, 10 years later. So load buffer, if we ever get to that point, we'll see. But then it means that I need to provide this function in a different way to Lua, which is the current step where I am at right now. So let me just update the details in the web page. So add support for LuaJIT profiler. Okay, but before that, we need to add support for Lua load buffer call. Okay, and so now where is this going to happen? It's going to happen somewhere here in the nerve bindings. That's where I would be loading the basic functions for Lua. We'll start with a state here and we get the state. So I could continue and use Sol to do the binding, but actually I'm not really sure how this would be done because I want to create a row level Lua function here. So let's just go another way and just assign the row function manually. How do we do that? A good question. I don't quite remember. I think I know that we can get something like this. So static return int, and that would be our load buffer taking a Lua state and returning an int number. No, or return 0. So let's make this an auto function, Lua state, and I'm going to use that. So from the Lua state, we should retrieve the content and the module name. So we should have 2 arguments on the stack. So and top equal Lua get top, I think. Yeah. Well, I mean, I can do a check here simply. There are no additional argument because it's not a member function or anything. Like this. Oh no, it's not check anymore. I mean, forgetting this every time. NV check. Okay, and once we have that, we get the first string. I think, I mean, it should really be just get string. I mean, toString. Come on. L, and that's the first argument, and that's going to be the content. And I guess I can just, is it safe to have it this way? I think load buffer is going to pop the content. So are you done loading this? Okay. I mean, Lua load is going to, or is it? I guess could be that this is not popping or pushing anything. So we'll probably need to maybe pop ourselves. So let's get a string from that. So that would be NV string content equal, and then NV string mode name equal. That would be this way. Then we pop those 2 elements. So 2 of them. So the stack is empty now. Next, we need to call this load buffer, and we get a result from that. load buffer X. Oh, that's from Sol. Okay. So just load buffer. L, the buffer that we have to load is content data. The size is content size. Note that I'm just using toString here, not toLString. We probably don't need to get the size of this string. It's not going to be a binary string. Or could it be? No, it. Oh, could it be? Good question. Let's see. I most probably have existing example of how to use toLString properly in the bindings. Yeah, just need to do it this way maybe to be safer. Actually need the 3 lines. So length should be 0, content string. And that will be what we have at position 1. And we get also the len. And then we say content is what we get from this, but using the length. Oh. Same thing then for the mod name. And that's the second element on the stack. Okay, so now we should support binary elements in the string. So we get the size and the name that we should provide here, that's a mod name. So we get a result out of this. If the result is 0, I mean, let's handle the errors instead. Error, syntax error. Or actually the other, I mean, yeah, no, maybe just this one. Then we have a string pushed on the stack normally. I mean, there's something going wrong with my internet connection. I need to check that. Okay, no, it's just me being stupid and clicking on that while I'm already there. Anyway, so it's going to push the Lua function on top of the stack if everything goes right. Otherwise, it's going to push an error message. So we have an error message on the stack in this case. So we can get this error message. I guess, yeah, just get this as a string again. Oh, we're going to throw an error, so. So that's what we have at the top of the stack. And Or could we maybe use Lua error? What is Lua error doing again? I don't remember if it's popping anything. Oops, sorry about that. So let's find Lua error. Okay, it's never going to return, but we can still pretend we return something. Interesting. So let's use that then. And we get the module name, and then we display the message. And I don't really like this message being on the stack at this point, so let's pop this. Then we still need to get the string. Okay. You don't like this function, I know that, but never mind. Then we have another similar case. For error memory allocation error. Okay. Oh, come on. Do not use else? Yes, makes sense. So we handle the two errors like that, and if we reach this point there is no error, it means that at this point we have the function on the stack. Yeah, so we can call it. It's a function taking no argument and returning. Oh, good question. What is it returning? It's supposed to return one value, yes? Okay, so we have this shank function on the stack. What do we do with this? As a Lua function, so we can call it, and it's going to return one result and not take any argument, because that's what we have in the setup. So it's a function taking no argument and supposedly returning a result, which could be nil. So let's call it this way. think we can just do Lua call. L number of argument is 0, number of result is 1. Is this returning something? Void. Yeah, because it's going to produce an error if a bit like this one, I guess, if something is going wrong. Yeah, if we were using pcall, then we could catch this error and report it. But the thing is, I actually don't really want to do that here, because then you're losing the full stack trace. And I think it's better to only have this at the very root of your Lua function calls. So let's stick with just using Lua call for now. And at this point, we should have this single. Well, we had the function on the stack, but Lua call will pop this function, pop the argument, and then push the result. So we should have one result on the stack. And that's the result of the function chunk call. Alright, so could be that this function is enough, but now we need to assign it somewhere in the Lua environment. So how can I do that? Maybe just yeah. And you would do set field or something. I mean, I need to push the function on the stack first. Lua push C function on the stack, and that could be load buffer. And then I do Lua set field, I think, or no, I need a table to do that. Set global, in fact, that's what I meant. Set global would be this, and then the function name is going to be just Lua load buffer. I mean NV load buffer. What is set global doing exactly? I'd expect this to take this function, pop it, and assign the this object to this key in the global environment. Let's confirm this. Oh yeah, I mean, this would work also. Okay. Good. So we should now have this MV load buffer on the stack. Let's compile this. And then we need to get back into this setup. And what we need to do here now, when we are supposed to load the module, what do we do? So we have integrated version using load buffer. What do? We just get a result local res from a simple call to mv load buffer, giving it the content as first argument and the module name as second argument. No, come on, module name like that. NV load buffer is not defined here. That's an interesting note. Could I? Where is this defined then? I think, yeah, we need to add this in the, no, not base, core maybe? Probably not either. So why is it not confused with this one? Global and none. Yeah, sure. Well, anyway, let's see if this works already. So we should not need the spot. And compilation is done. So what do you think now if you just do the normal? I mean, we can do the profiling at the same time. Oh, I mean, it's running. That's pretty surprising already. Good. Let's just finish and we'll see. Oh my, it's done. But yeah, the module name here is still just string. I don't know how to tell it to get the chunk name. Come on. So it could be that or what we did here is completely useless, and the issue we have is actually rather in the profiler part here. So let me think a little bit. Okay, so I try another thing, and this one is giving me better result here. I try to not use the function I implemented, not use a load string, and just use require on the module name. And in this case, yeah, it's working. I get the module name, which is cool, but I actually really don't want to use require here because in the end I want to be able to bypass the file system completely and load the Lua modules from some kind of package or memory content. So yeah, we need this load buffer somehow. So I need to figure out what's happening here, which is different, and how we can replicate that somehow. So I'm investigating. Oh, okay, I think I may have something here. If we look at the definition for the require function, we see that there is a part where first, yeah, you're going to search for the package loaded module. If you add that, you return this as a result of the loading. That's okay. But the other part is this one. It's trying to find a loader for the module. To find a loader, it's first going to search in package loaders. So for the default value that we have in package loaders here, the require function will query package preload the module name. If it has a value, this value, which should be a function, is a loader. Otherwise, require search for a loader using the path blah blah blah. Okay. And in fact, I found an example of that. I think, where did I find that? Yeah, this one. So if you have a string and you set this string there's a function returning something. It's not really, load string is going to, give you a result. That's return. I mean, it might not return anything. We can just have a module here, I think. And we may return or not return something. Okay, so that's what we want to push in the package preload, and then we could just still use require to do the actual loading. Let's try that. That's basically, this means that the function we have just implemented here is useless because we still want to use a load string and perform this in 2 steps. So never mind. So this was working, but let's try the other option here, which is to use load string to load the content. We have a module name here, but it doesn't really matter. And then instead of executing this function right away, what we will do is we will set this function as package preload, and using the module name equal fung, and then and then we do the require just here. So local res equal require this module name. Okay. So the content that we have is still provided from memory. We build a function, then we just store this function in preload before calling it that. If this works, that's great. Okay, it's running at least. Okay, but unfortunately, this doesn't seem to work. We still have the string part. Whereas if we just comment that, in fact, then require will proceed with a different path and will give the expected result. Let's just save the file and confirm. Yeah, so this is really a pain and I need to investigate further. Okay, so I think I might be holding something interesting here. So I've been looking into actually the sources for LuaJIT and all, trying to figure out what's happening when you try to load a string or you load a file. And I actually could not find anything significant so far, but yeah, I need to maybe dig a bit deeper in that direction. But first, yeah, I was trying to do the load here with the load function, just load content module name in text mode. When I use that, it's failing again. It's just giving me string. But then when I use load file here, providing a file name, still in text mode, then when I use the function, this time I get the appropriate name. So I'm thinking it could be that really this is working, but the name that we provide for the chunk here should be some kind of regular file name. Maybe the provider is expecting to find .lua at the end, or a dash for the location or something like that. So let's say we just provide fname here and we'll load from the content. So we'll execute again and see if it's making any positive difference. And no, unfortunately, using this file name here doesn't really help. We still have string. My. So yeah, I need to investigate further on what this load file is doing now. Oh, I think I now have this working. So yeah, I got the load function to output some file name, which is great. And in fact, this all came from the definition of this function here. That's what we call at some point when we load a file. And you see that if we have a valid file name, we'll do something like pushing this file name as a chunk name, but adding this at character at the beginning. So I thought, okay, maybe this is the symbol that profiler or something is using to figure out that this is a file. And indeed, if you add this in front of your file name, then it's going to work, which is cool. Now, maybe we can extend this a little bit. Maybe the file name, you don't really need everything at the beginning. I can just use the module name here. And I probably should not keep the points in the module name because, yeah, there's certainly a mechanism to prevent that, but you're just returning the file name here, and I'm thinking maybe I can, if I replace point by underscore, get a more complete path for this file. Or I could maybe just keep point, we'll see. So let's try with this first. Super cool. This is working as expected. We now get the full path somehow for the module of interest. Now just wondering if it will work if we keep using a point. Probably not, but... And do we need point Lua at the end? That's a good question. So let's try to remove this. Yeah, but that's the Lua file in the end. Could make sense to keep the point Lua. Okay, so point Lua doesn't seem to be that critical. So next step is, can we just keep the points in the name? So we will not even change anything in that module name and keep the points. In which case, all we really needed to add was this hat symbol. Okay, and indeed, it's still working, so we can keep the point. Oh, we just have to specify this at. So, which bring me to the other concern, which is, I mean, maybe you can just discard this part and use the function I had here. But now, now just add the at symbol here to the module name. I mean, there's a good chance that this will work just fine and produce the same result here. Alright, this is working just fine also, and we have the appropriate module names now. So good. I mean, I can just commit those change. We have some work here done with this load buffer function added, and we have the appropriate mechanism to get the module name reported in the end. Here we just added, what is that? I don't think it makes sense to report the full path anyway, so it's not going to change what we have here. Okay, then in the, yeah, we did some cleaning, and here we added this function to do the loading. Load buffer and the load buffer. Okay. That's good to know. I could also maybe clean this now, but I think, yeah, maybe I should keep it a bit longer just in case. So good. So what we have done so far, we have added support for this load buffer function, and we have been investigating, yeah, what's happening with require and load, and just figure out how we can force the profiler to find a file, even if we don't really have a file. Next, we need to start digging into the profiler result now and see if we can improve on that. Okay, so first starting to investigate here what we can do concerning this asName function. So this is a function from the type class, and in fact all the entries reported here are inside this asName. So it's telling us that most of the time, I guess, is spent on this line 312, and that's here when we do a sub, apparently. Then also on 300, that's at this location, so manipulating some strings again. 282, that's the first line, in fact. So yeah, all of those are inside the function. But we could consider, yes, should we improve on this and optimize this part? But first I was trying to figure out where do we actually use this asName function. And one thing I'm noticing, so we have that in type here. That's a definition, and also here we call the base function. So we are calling this recursively. But then I thought, okay, let's check also here, and we have this in type manager with as type tname, and I think it's getType. And what I'm thinking here is this could be optimized, because we keep a list of types, but we could also keep a mapping of the type byte names. So we could say that we have, I mean, this should be in the reset, right? Setting this, converters, and templates. Yeah, so we can just call reset here. Okay, and in addition to the types here, we should have type all types or something like that. Name map type name map. Okay, then in this those two functions, what we should do is simply check the name map first. So we say local t, so check. Name map, and we try to get this. So if t is not nil, then we simply return t. Oh, I mean return. Well, in fact here, if it's a boolean, so just return this is okay. Because it should be registered anyway at this point. So if this is not nil, then we're good. And I mean, that's all we need to check here. So we don't even need to go into this additional part. What kind of timing did we get? 46 seconds, amazing. Check if a given name was already registered for the type. Okay, so the parameter is tName, a string. And the return is a boolean. Okay, next the other location where we call this is in getType. That's where we need to first check if we have this. I'm wondering if we could maybe just throw an error in this case. We'll see just after. So getType equals self type name map with this name. If t, then return t. If not, then if we have this, we found this type with the corresponding name, then we should add this to the mapping. And return that type directly, and otherwise we return nil here. But I think this could still be optimized a little bit. Let's just see if everything is still okay. I guess we're not breaking much. Should not be breaking much. Oh, that was super fast. And that's only took... Okay, good. So 25 seconds now. We already almost divided the time needed by 2. And there's no change in the mapping, in the binding generation, so we are all good. But next, I thought, yeah, maybe this could also be discarded. Where do you use getType? I guess, yeah, we have a lot of entries for that one. No. Like this, getType, blah, 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 blah. Let's see if we can just throw an error instead. So, no type. No type registered for that one. And when that's called, because when we do add type, let's see, what do we have? Where do we have add type? So that's where we don't want to get the type. Instead, we should simply check if, yeah, we should do that internally. It should be cheaper if as type with this type name. Then we get this previous type and we check it's the same thing. And we return, yeah, the same thing again. Otherwise, we can add that type. And in fact, when adding a type, what we should do, since we have all those names already available for it, get names, we should probably register those names in the type name map. So let's say tnames equal so for tname in I mean, you have the ID and the name itself. So for each of those, we need to add an entry in the type name map, which we expect to be nil. So this should reduce again the number of time we need to go into the asName function. I mean, we still maybe have errors, yes. No type register for name. Where do we have this? Get type. Oh yeah, that's another case in parse class. clangParser 1110. So again, we first need to check. Oh, wait a second. Does it make sense? I mean, wait a second. Okay, so I'm not quite sure that this is correct, what I'm doing here. I mean, because when you get type here, could still be that that type name is not registered for any type, but when you do that, you will find that it should actually apply to an existing type. I think there are situations where this may happen. If this happens, it means that you're modifying the list of available types by name here. And as type is not applying that. So that could be a problem. So let's not modify it too much, and let's just say for now we just return in if we could not find anything and see if it's keeping the bindings as is or if it's really messing something up. Yeah, typically type name already registered. probably because of that. Right. Let's see. No, not quite. Type name already registered. Adding template name alias. Oh, I mean, you're adding this alias multiple times? Really? No, that can't be happening. Come on. Oh, seems we are. Okay, so that's not good. Let's do a check here. So only if it's not already registered, then we can add it. And in fact, if it's already registered, we should not even do anything like that. Add name, give name, blah blah blah, return. And then if we already have this, okay, so let's check that at the top. So if the name is nil, we don't do anything. If we already have that name is a list of names, then we don't do anything either. Okay. An error. This is not good. I mean, adding this alias to this type. How could this be happening? We're only reaching that here. Oh, that's because we're modifying the name, in fact. Okay, so we may not modify the name in some cases, right? So if it's not a template, then we don't go in this part. If we have a name, we return, and then we would add the name as provided as parameter, but we may also modify the name here. And so if we should check again here then, if we already have this name. Okay. Oh my, I mean, what are you doing? I need to think about this. Let's display all the type names. There is only one, so it's not coming from this existing type. So what does it mean? If we have a type already for that, I mean, if it's already in the list, we should find it. Or maybe we're not trying to find it. Add type, get the name. And what is the name, the main name itself? That would be type get name. Okay, so we have this new name, and it's not exactly the same thing as the previous one. Okay. So what does it mean for us? The strange thing is, why don't we have this main name? Okay, wait a second. This is not really the name corresponding to that. Whoa, 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 whoa. No, more thinking required. Okay, so I'm a bit at lost here and trying to understand what's happening with this already registered name. But I think what we can do is just first check if the type is already the same. So if self So if it's already assigned, then we check that we are already talking about the same type. Let's just display all the names. And get all the names we have here. Okay, maybe this will just not happen. Oh, that's really not good. We are duplicating types here somehow. They have the same names, but they are they are not exactly the same object. Bad them. So still stuck on this issue with multiple types created for a single type name. Now I'm thinking maybe I should also, when I update a given type by adding a name, so which is a name function, I should also reflect that into the global mapping that we have in the type name. So that's why I'm preparing this function. I add type name. Here we expect that this name is not already registered. Or if it is, it should point to the same type. Yes. That's where we should do this check actually. That would be, we compare the new type, or the names from the new type to the name on the existing type. So if it's already there, then the type should match. Otherwise, we can register this new entry. Next, we need to also, we have access to the type manager here. Yes, type manager. And when we add a name, so add name. Because if we check, fine, get name, this is really just returning this. So when we add something to this list, that's really strange. Okay, so this is where we should make the recording. So type manager and type name. So the type is our current object and the name is its new name. So where does this help? I mean, we also need to call that at the other location, I guess. Oh man. Okay, this is getting bad. Okay, I think this error is coming from the fact that when I'm resolving a type, I'm preemptively creating a new type with a name. So here I should not yet do the registration in the type manager. We'll only do that when we get to the add type function. But then when we call add name, this is something that we do dynamically. Oh, but we might be doing that before the type is registered. Yo-ho-ho, good question. Let's see anyway. No, still not. And a mismatch. Type manager 134. So here when adding. That is not good. Come on. Okay, this recording is too long already, so I'll have to figure this out in another session, I guess.